Hi guys, in this video I'm going to walk through with you this nickel number 11 container with most water. So we are given n non-negative integers a1, a2 all the way to an, and where each represents a point of coordinate. For example, I comma a1, and n represents a vertical line. So for example, it connects the two endpoints like I, comma AI and I0. Find the two lines together with the x-axis forms a container and it contains the most water. So let's look at the example. So for example, for this one, the height at the first bar is 1, the height at the second bar is 8, and the height the third bar is 6. And the maximum, the biggest container contains the most water is for a bar is on the left hand side here, and then also the right hand side here. So that forms a container. That's the biggest one among all the possibilities. I mean, we can have a container forms from this bar and this bar, but it's going to be very small because the the length is not big. The length is not big. The width is not long enough. Also, the height is really small because when we pour more water in here, the water gonna spill, right? So after all the tries, and then we can see that it's the biggest one. It's from this A, the height of 8 and so the height of 7, and then forms a container looks like this. So the area of this is gonna be 7, which the height of this bar, which is the minimum of these two bars, and also the distance, which is the length, which has distance of 1, 2, 3, 4, 5, 6, 7. So 7 times 7, 49. So that's exactly the output. And for example, this example, and it's more trivial. It's only 1 and 1, so the output is just 1. And for this one, the biggest container will be formed from the first bar and the last bar, and it's going to be 4 times 4 because the 4 is the height, and the width is going to be the distance between the 2 points, 1, 2, 3, 4. So 4 times 4 is 16, etc. That's all the examples. And as you can see, a brute force approach is going to be running through all the possibilities, and then find the biggest one, and that gonna take the big O of n square. That's gonna be slow, but we can start with that and to see what happens to just do a brute force approach. I doubt LeetCode is gonna accept that solution, but I think it's good to use that to build up the intuition. So for all the bars, so I in the so we can use the enumerate. So I and height in enumerate height. Also, we can have anything that is after that. So for maybe we can use I use the left, and then for I right enumerate. In height starting from I plus 1. This is J in here. Yeah, and then we can search for all the combinations this way. And we can have a max area. Oh, it's the same name of the of the function. We can use we just use area. Area we start with 0, and we can calculate the area for all the possible combinations. So we can call calculated area is equal to, okay, so what's gonna happen is the formula for calculating area is equal to the width times the height, or we can call it like a distance times height, right? And in this case, the distance, what is going to be the distance is going to be j minus I, right? Because that's capturing the distance. So it's I and j, they are index. Also, they're capturing the distance. Yeah. Because j is always greater than I. Oh, not necessary in this case. I probably should change that to, yeah, I probably should change that. So JR, so for J in range, the length, that the range starting from I plus 1 all the way to length of height minus 1, because we need index. So yeah, so j is always greater than I, so it's going to be j minus I. So that's the distance times the minimum of the height of the two bars. So that's going to be L. And also the height. So that's L, and also that's L stands for the left bar, right stands for the right bar of J. So yeah, like this. Okay. So that's gonna be the minimum of the L and J, L and R. And yeah, so that's calculated area. So that's a brute force approach, and then we can compare. So so area, right? Okay, I can call it like a max area, M area. I rather not call it max area because it's exactly the same as the name of function. So avoid confusion, I just call it M area. Equals to the max of the prior max area and the current that is just being calculated. So we get that. So we're constantly updating after each iteration. And then after the double for loop, which is expensive, and then what we're going to do is just return it. Return the M area. So let's see what happens. Okay, there's an error. So it's only 40 instead of 49. And 40 seems like a 5 times 8. Let me pause the video to try to figure out the error. Yeah, here I don't need the negative one because for the range it's automatically omitting the last element, so that I don't need the negative one. So that's why I just delete that. So now it works for this specific example. However, if I run it through the evaluation engine, it's gonna be timeout because it's not very efficient. Let me pause. Yeah, don't need to pause the video, so we can see time limit exceeded. So we need to come up with better solution than this, taking big O of n squared. So what we can do is to use a 2-point. I mean, but this approach is giving us a very good intuition of how it works. So we can build up on top of it. But one approach would be use a 2-pointer method. So we have a left pointer, we have a right pointer, and then update the left pointer and the right pointer when we calculate the areas. So yeah, let's get to the code, and then you know what I'm talking about. So I'm gonna comment this out. And now we can use the 2-pointer method. So we need a left pointer, also the right pointer, and so the left pointer starting from 0, and the right pointer starting from the end. So that's going to be the length of the height minus 1. And so we have that. And then when we move toward the center, because the biggest distance, because we have this area formula, so the biggest distance will be the L and R is really far apart, because in that case we have the longest distance forming the longest width. So while they don't cross over, right, the left pointer is less than the right pointer, and then we can calculate the area. So, and I'm still using the same name, calculator area. That is equal to the distance, which is R minus L, right? So that's the distance and times the height. The height is still the minimum. I'm just grab this formula. I don't need to grab it. And so it's the height. Look at the L index. And sorry for the confusion. Here is the left bar and the right bar, but in here is the left pointer and the right pointer. I'm just too lazy to rename them, but hopefully you're following. And here will be the right bar. So here is how we update the pointer. So if the left height is greater than the right height, and what we're going to do meaning that the left height is better than the right height, meaning it can contain more water. So probably for good height, we want to keep it, rather than we can remove the bad height to search for, because each time when we move toward the center, the distance is going to decrease, right? So in order to compensate the decrease of the distance, we want to remove the bad height. So so that means we can decrease the right hand side of the bar. And how can we do it is to decrease the right bar. I mean, move and just allow the left bar. Just allow the right bar move toward the center, and then holding the left bar a constant. So And we can, by the same logic, we can do the same thing for the right bar. So if the left bar, so in this case is the right bar is higher, and if that's the case, we get rid of the lower height, which is the left bar, so we increase the left by 1. I mean, in the case where if they are equal, it doesn't matter which one we want to get rid of. So in that case, I just can choose each one of them, any one of them. So I just probably choose this one. It doesn't matter actually. And then oh yeah, so in here we can update the max area as soon as we calculate it. So oops, yeah, I forgot to return. Let's see what happens. It works. Let's see if that was working. Oh, it's not working. Let me pause the video and to try to see which one is not working. Oops, sorry, that statement is not right because it's just doing one more comparison after that. So I need to use an else statement. So either this statement or that statement. So, and that clears up the issue. So after that, it runs. So you can see, yeah, it kind of varies the result. Sometimes like 9%, now it's like 61%. So it seems pretty efficient. Sometimes 31%. So it fluctuates. And the one-time complexity for this solution is a big O of n because we only have one pass of the entire height array, and so it's much more efficient than the big O of n squared. Yeah, so for space complexity, we only need one number as the maximum square. So so this is big O of 1. So yeah, so that's the solution I can provide in this video. I hope you like it. If you do, please like and subscribe to the channel. And thank you for watching. Hopefully see you in the next video.